Most of the test takers consider quadrilateral as a highly tricky topic. They just ignore the basic fundamental principles of the quadrilateral, and this video is all about the basic fundamentals of quadrilateral. Starting with quadrilateral, a quadrilateral is a closed shape and a type of polygon with 4 sides, 4 vertices, and 4 angles. And the main thing is that the sum of interior angle in a quadrilateral is always equal to 360 degree. And there's a formula to find the sum of angles in a polygon, that is n minus 2 into 180, where n is the total number of sides of polygon. As quadrilateral is a polygon with 4 sides, that's why n is equal to 4, and 4 minus 2 into 180 is equal to 2 into 180, which is 360 degree. Another important property is that the sum of exterior angle is always equal to 360, and this holds true for all of the polygon. And this property is really helpful in some cases, and it is used as a shortcut way to find the relevant answer to the question. Now to discuss the quadrilateral, it is ideal way to discuss is through its hierarchy. So let's start with the parallelogram first. So what is it? Is a parallelogram. It is a quadrilateral with 2 pairs of parallel sides. So this is a parallelogram in which these 2 sides are parallel and these 2 sides are parallel. So there will be 2 pairs of parallel sides. Coming to the properties, first thing is that opposite sides are equal in length. So AD and BC are opposite sides and these are equal. Likewise, AB and DC are also opposite sides and these are equal. The next property is opposite angles are equal in length. That means this angle D is equal to angle B and this angle A is equal to angle C. The next property is diagonal bisect each other. First of all, what is a diagonal? Diagonal is a line that is connecting opposite vertices. So one diagonal is DB, another diagonal is AC, and they are intersecting at one point, and the property is that the diagonal bisect each other. That means at the point of intersection there is a equal length on both sides. So if DB is diagonal, so if this point is E, that means this BE is equal to ED, and for this diagonal AE is equal to EC. So diagonals are bisecting each other. And the very important property that the consecutive angles are supplementary. That means that these sum to 180 degree. So if I consider this parallelogram, that means this angle D and angle A sums to 180 degree. These are consecutive angles. So angle D plus angle A is equal to 180. Now if I consider these two angles, angle A plus angle B is equal to 180 and angle B plus angle C is equal to 180 and angle C plus angle D is equal to 180. So the sum of two consecutive angles are always equal to 180 degree. Now the next thing is to find the area. To find the area of any parallelogram, any quadrilateral, we just need one base and height which is with respect to that base. But this is a bit tricky in case of parallelogram. If I consider DC as a base, I need to find this perpendicular distance which is a height. So in some cases, you will see question in exam that will provide this angle, and most of the time those angle will be forming a triangle of 45, 45, 90 degree or 30, 60, 90 degree. So these are the most common Pythagoras triplets you will see in the triangles. And for example, if this is 45, so if I consider this point as F, so this will be D, A and F. This is 90 degree. If this is 45 and this is 45, so that's when these two sides are equal, and based on the ratio of 45, 45, 90 degree triangle, if this is X, this is X, that will be X under root 2. So based on these ratios, in most of the cases, this will be helpful in finding the height so that you can find the area of parallelogram. And the diagonals are dividing the parallelogram into two equal portions. So if I consider DB diagonal, so this portion and this portion is equal. So area of one triangle formed by the diagonal, if I take twice of that, that will be area of total parallelogram. And likewise, I can consider same for the AC diagonal. This portion and this portion is equal. So finding the area of one and multiplying that will be 2. That will be the total area of parallelogram. So this is just a summary of all the properties we discussed earlier. Now let's move to the rectangle. First of all, let's try to see these in terms of hierarchy. After parallelogram, there is a rectangle. There's one main difference in rectangle. Rest all of the properties of rectangle are same as that of the parallelogram. We can define a rectangle as a quadrilateral in which all interior angles are 90 degrees. And this is a special case of parallelogram, but there is extra limitation that all angles are fixed at 90 degrees. As in the parallelogram, all angles are not equal. The opposite angles are only equal. But if I restrict the case that all of the angles are equal and 90 degree and rest all of the properties are same as of the parallelogram, so that will become a rectangle. Just in this case, rest all of the properties are same as that of a parallelogram, but with one limitation that all of the angles are 90 degree. Now let's see some properties. First thing is that diagonals are congruent, as opposite sides are equal and each angle is 90 degree. So to find the diagonal, if I connect this, and for example this is A, B, C and D, I know this side and I know this side. So what will be a diagonal? That will be, we can find that using the Pythagoras theorem. And because these two sides are equal, and also in this case these two sides are equal, so diagonal will be exactly same. This BD will be equal to AC. And the next thing is how to find the diagonal, and that is, for that we need to use the Pythagoras theorem. So if I connect this, and if the width is W and the height is H, so what will be the diagonal? That will just we can find that by using a Pythagoras theorem. If I consider that A, so using Pythagoras theorem, A square is equal to W square plus H square. So this A square is equal to W plus H square, and to find the value of A, just take the square root on both sides. So A will be equal to W square plus H square, and that will be a diagonal. And this is just a brief summary of those properties, and rest all of the properties are same as that of parallelogram. Now let's move to the rhombus. Now rhombus is another type of parallelogram, but with some limitation. First thing, what is it is a rhombus. That is a quadrilateral in which all four sides are equal in length. And this is a special case of parallelogram with extra limitation that all four sides are equal. In case of rectangle, all four angles are equal and rest properties are same as that of parallelogram. But in case of rhombus, all four sides are equal and rest all of the properties are same as that of parallelogram. So this is rhombus in which all of the sides are equal and rest all of the properties are same as that of parallelogram. And there are some extra properties. The first thing is that diagonal always bisect at 90 degree. So if this is a rhombus, these diagonal, this BD and AC are diagonals and they are bisecting perpendicularly. That means the angle at the intersection is 90 degree and there is a bisection. If I consider this as O, so that means OD is equal to OB and OC is equal to OA. And these are bisecting at a 90 degree. The next thing is to find the area. The usual way is to find the area is to take a base and find the height relevant to that base and just multiply that. But in case of rhombus, you can't do that in all of the cases because of the angles. So in that scenario, you need to consider two diagonal lengths and just multiply those and divide by 2. So you can find the area of rhombus in two ways, either by considering base and altitude, or you can use the diagonals as well. So if I consider this as a rhombus, so if this length BD, if I consider this as the first diagonal and this CA as a second diagonal, so what will be the area? That will be D1 into D2 divided by 2. This is one way. The other way is if I divide this into two triangles. So if this portion is one triangle, so I need this base and this height, and likewise this is the another triangle. Just find the area of these separately and just add both. So you can either do this way or you can use this way. It's totally up to you. But it depends from question to question. If you are provided with a base and height, you can use simply use the area of triangles, and based on that you can find the area. But if you are provided with the diagonals in that scenario, you need to multiply the diagonals and divide that by 2. And this is very helpful because we know that they are bisecting at 90 degree. So in most of the cases, to find the area, we need to use this property of bisection to find the either of the length, or to find the length based on the hypotenuse. So it depends from scenario to scenario. So this is the brief summary of those properties which are different, and rest all of the properties are same as that of a parallelogram. Square is a very important type of quadrilateral, and you will see more question in exam regarding square as compared to the other types of quadrilaterals. Now square can be defined in terms of parallelogram, in terms of rectangle, and in terms of rhombus. First of all, what is square? A quadrilateral in which all of the four sides are equal in length and all of the internal angles are 90 degree. So this is a special case of rectangle in which all of the sides are equal. Earlier we discussed all of the angles in rectangle are 90 degree. Now if I enforce a limitation that all of the sides are equal, the rectangle will become square. And in case of rhombus, we discussed earlier that all of the sides are equal. Now if I enforce the limitation that all of the angles are equal as well, that rhombus will become a square. Now if the question is about the rectangle, you need to consider the special case of square as well. And if question is about the rhombus, you also need to consider the special case of square as well. And that's how the examiner tried to trap you in question. So that's why it is very important to understand the quadrilateral in terms of hierarchy. Starting from parallelogram, we move to the rectangle and rhombus. The rectangle and rhombus both are having same properties as of the parallelogram, but with some limitation and few new properties. And square is a special type of parallelogram having same properties, both of the properties as of the rectangle and as of the rhombus, with few extra properties. So if you see a question regarding parallelogram, you should incorporate rectangle, rhombus, and square. If you see a question regarding rectangle, you need to consider rectangle as and the square as well. And if a question is about the rhombus, you need to consider the rhombus as well as the square. Now moving further, first of all, how to find the area. If I consider as all of the sides are equal, each side is S. So as for area, we need base and height. So if I consider any base, the height which is perpendicular to that is also the same. So the area for this will be S into S, which is S square, and S is one of the length. This is first way. The other way is by the use of diagonal. Because both sides are equal and the angle is 90, if I draw the diagonal, these are bisecting the angle as well. This will be 45 degree. This will be 45 degree. So if I consider this as a separate triangle, so this will be A, C, B, this is 90 degree. So if this is S, this is S, this will be S under root 2. Using the 45, 45, 90 degree triangle, if this is S, this is S, this will be S under root 2. I will attach the video link of the triangles so that if you are new to this, you can watch that. So if I know the diagonal, for example, this is D, so what will be the area? That will be D square divided by 2. So either you can find this using the sides of triangle or using the diagonal. Now moving to the another important type of quadrilateral, which is trapezoid, or sometimes you can say as a trapezium. So a trapezoid is a quadrilateral which have at least one pair of parallel sides. So these two sides are parallel, and these two sides for time being are not parallel. We will see several cases of trapezoid. The first thing is to find the height. To find the height, what exactly we need to, these two sides are parallel. This side CD is parallel to side AB. To find the, and this CD is equal to A and this AB is equal to B. To find the height, first to find the area, first of all I need to take the average of these two parallel sides. So that will be A plus B divided by 2, and I need to multiply this with the height, is a perpendicular distance. So in this scenario, if height is h, so that will be the area of this trapezoid. Now there could be another way. In some cases you need to divide this into two triangles and one rectangle. So based on that you can find the area of this, but that will depend on scenario to scenario. There are many other ways to find the area of trapezoid, but in exam you will most of the time you will see only these two cases. Either you need to divide these into two triangles and one rectangle, or you need to find the area using this by taking the average of two parallel sides and multiplying that will be the height. Now there are two types of common type of trapezoid. One is isosceles trapezoid, a trapezoid in which two non-parallel sides and base angles are equal. So if you see this, this A is parallel to B, but this side and this side are non-parallel. So in the isosceles trapezoid, these two sides are equal. This is C and this is C, and the base angle, these two angles are equal. So based on that, if you draw a perpendicular from this position to downward, this is a perpendicular. So if this is A, this will also become A. So what are these two sides? That will be, because the remaining will be B minus A, and because this angle is equal, this side is equal, this length is equal, so these two lengths must also be equal. So what will be that? That will be B minus A, and there will be half on both sides divided by 2. So this will be B minus A divided by 2, and this will be B minus A divided by 2 as well. So in this set, this is very easy to find the area. Just divide into two triangles and one rectangle. Now moving further to another type, which is a right trapezoid. So in this, there are two angles which are 90 degree, and this is a very frequent type of this involves a very frequent type of exam question in which you need to find the parameter of this shape. And for example, if you are provided that this angle is 120 degree, so and we know the length, for example, this is x and this is y. So what will be the parameter of this trapezoid? So the way to solve this is to draw a perpendicular from this to this side. So this is 90 degree. This is 90 degree. If this is 90, what will be this? That will be 120 minus 90, which is 30. So this is 30 degree now. This is 90. Because the sum of angle in a triangle is 180. So what will be this? That will be 60 degree. So now It is very simple. This length is equal to this length, this is x, this is y. Now we have 30, 60, 90 degree. This is 30, this is 90, and this is 60. This is y. Now simply use 30, 60, 90 degree ratio. So if this is x, for example, this is a under root 3, this is 2a, and in front of 60 degree, which is a under root 3 is equal to y. So a under root 3 is equal to y. So a will be y by under root 3. So in front of 30 degree, I have a. So this will be y by under root 3. And in front of 90, that is 2a. So 2 into a, which is y by under root 3. So just remember, in this scenario, you need to divide this into a rectangle and a triangle, and you can find the parameter as well as the area. Now this is just a brief summary of all of the properties of the parallelogram, rectangle, rhombus, sphere, and trapezoid, which we discussed so far, with respect to the sides, with respect to the angles, diagonals, and the formula. Now if we see the hierarchy, starting the quadrilateral with parallelogram, if we move to the rectangle, the limitation become that all of the angles are equal. If we move from parallelogram to rhombus, all of the sides are equal. And now from these two, if we move to the sphere, angles and sides are equal. And in trapezoid, if these two sides are and these two angles are equal, this will be isosceles trapezoid. And if two angles are 90 degree, that will be right trapezoid. There is another type of parallelogram of the quadrilateral, which is kite, and you won't need to know the properties of the kite with respect to the exam. Now there are some important isoperimetric theorems regarding the quadrilateral. The first thing is that among all quadrilaterals with the same parameter, sphere has the largest area. This is really helpful if we are dealing with the could be case scenario questions in which we are provided with the parameter, the total parameter, and the question is about finding the area. So in that scenario, for time being, we are restricting to the quadrilaterals. For the quadrilateral, if there is a scenario that parameter is same, so the maximum area is always of the sphere. So in this scenario, we can get the maximum range of area, and the minimum range could be greater than 0, but for the maximum range, the area must be equal to that of sphere. And the inverse is also true, that among all quadrilateral, now if the area is same, the least parameter will be that of the sphere. So in first scenario, as we are dealing with quadrilateral and we have restriction that parameter is same, the maximum areas of the sphere. And if there is another limitation that the area is same, the least parameter will be that of the sphere. And you will see questions relevant to these in the data sufficiency of the GMAT and the quantitative comparison questions of GRE. So try to understand these properties. That will be really helpful if you want to score a perfect score. Now this is a very interesting property and highly tested in exam as well, that for every parallelogram there is a rectangle with a larger area but with the same parameter. To understand this, if I consider this BADC as a sphere and this BADC as a parallelogram, and the thing is the parameter is same, so that's mean this side is equal to this side is equal to this side, and this D dash C is equal to DC, and this side is same for both. As now we can see that the parameter is same, but if you see the convention of the ETS in the GRE, that you can't assume, someone may ask that we are considering a two-dimensional geometry, and as we can't assume the figure to be drawn exactly to the scale, then why can't we assume this AD to be exactly as at that of AD? Now, why can't we assume this line exactly at this line? The reason is we can't assume, as per the ETS convention, we can't assume this line to be exactly on that unless this point is somewhere on that line. That's why if they consider the area of this A dash D dash C B, the base is same but the height is greater. For example, this is H1, and for this parallelogram, this could be somewhere near to this, but this can't be exactly at A dash D dash. So this will be, for example, H2, and we can see clearly that H1 must be greater than H2. So the area for first one is BC base into height, and height is H1, and for area, this is for this one, and area for this one is BC into H2, and this BC is same, the only difference is in the height, and H1 is greater than H2. That's why the area of this upper BA dash D dash C is greater. Now the next and very interesting property, and you can call this a theorem to get an idea, that for every rectangle that is not a square, there is a square of larger area but with the same parameter. To understand this, if I consider this as a square, so let's consider this thing length as y and this length as y, because this is a square. So this is x and this is x. So what will be this length? This length will be y minus x. And what will be this length? This length will be y plus x. And in this, let's call this A, B, C, D, E, F, G, and H. And in this, A, B, C, H is a square, and this A, D, F, G, this is square, and this A, D, F, G is not a square, a rectangle. Now, if you see the parameter, first of all, if I consider this, what is a parameter? This length is y, this is also y, this length also y, this length, because it's a square, so this will be equal to 4y, the parameter for this. And what is the parameter for this one? So this length is y plus x into 2, because these two lengths are equal, and this is y minus x. 2 into y minus x is equal to 2y plus 2x plus 2y minus 2x. So this is equal to 4y. So both of the parameters are same. But now if we see the area, so if I consider, now let's make this, to understand this, let's make this as a quantity comparison question, and this is whole is y, this is y, this is x, so this will be y plus x, and if this is x, so this will be y minus x. So if I see the consider quantity comparison question, so quantity A is the area of square and quantity B is the area of rectangle. So what is the area of square? That is y square, because one length is y. And what is the area of rectangle? And that will, this thing, that will be y plus x into y minus x. So this is y square, this is y square minus x square. Now, as we discussed in the quantitative comparison strategy, that we usually don't know what is the sign in between, but we can perform the algebraic manipulation in this. So if I subtract y square from both sides, this will be 0, this will be minus x square. And if I add x square on both sides, this will be x square and this will be 0. That's why the area of the square is greater. And this is what the property is For every rectangle, there is a square of larger area but with the same parameter. The parameter is same, but the area of the sphere is greater as compared to the rectangle having the same parameter. I hope you find this video helpful. In case you are having any doubt, you can ask in the comments, and if you want me to make any specific video on any specific topic, just let me know.